It's an honor to introduce Christine Yan. She's from San Francisco. She is the CEO and co-founder at Honeycomb.io, and her talk is The Future of Developer Careers When Dev and Ops Meet. Christine, we are happy to have you here. The stage is yours.
Hello. Thank you for having me. Hi.
Hi.
I'm Christine, and I'm a dev. Recently, two of my worlds collided. I was thinking about this talk, and I attended my first motorcycle track day. For anyone who isn't familiar, track days are when a racetrack opens up its doors for motorcyclists to come and ride around. This sort of image is what most people associate with track days. Because for some people, riding fast is the fun part, and track days are where you get to do it the most. But really, the point is that it's a place where you can practice. Lots of people go to the safe environment where you can build up riding skills, where there are interesting turns, no obstacles for hundreds of feet. Because the real world, where we live and have to exist and usually have to ride, is not safe of unpredictable obstacles. Despite having all the skill in the world, the most important thing about writing is to assume that everything is out to get you. Because we won't know when a car door opens in front of us and might cause an early, painful stop to our ride. Can you see where this is going yet? Track day is like our dev environment. We can play around, we can write beautiful code, we can try things that will never scale because it's fun and we want to. Production is the real world. It's full of noise, got some malicious actors, but mostly it's just chaos, and it's entirely unpredictable. If we're lucky, we can build up enough skills in development. We can make our code stable enough that we are able to take those unexpected scenarios in stride. But if we're not, our code might throw exceptions, our software might get slow, or our systems can go down entirely. These two concerns used to be nicely separated. We write code in development, we hit deploy, it goes to prod, done. Similarly nicely separated, it used to be that developers worry about logic working in development, and ops folks would shepherd it and make sure that it stayed okay in production. Maybe nicely wasn't the right word. There was a separation of concerns. But over the last 5 or 10 years, there's been a shift in that attitude. There's been a shift in that sharp line between the two, and a change in slogans like these. Even the head of AWS is making these statements and changing his teams around this. More and more engineering teams are looking at memes like the girl in the house on fire and asking them what it would look like to have more developers assuming some of those traditional ops responsibilities, to think about code running in production as our problem, the same way code running in development is. That nice separation of concerns we used to have, that nice clean wall, doesn't really exist anymore. Shouldn't really exist anymore. As we all introduce more complexity into our system through breaking a monolith down to microservices and adopting Kubernetes and orchestration, pulling in serverless functions, dev and ops have to work together to keep our services reliable. Boundaries are blurring, bridges are being built. It's not enough anymore for code to work on our machines. So when I think about the future of dev careers, I think about developers in production. And the best way to enable that is through observability, to pull together tooling and practices so that everyone can understand our systems in production based on the signals and telemetry our software outputs. There are many ways to get developers comfortable in production and into this new phase of the software development practice. Here are some traps along the way. I've seen ops folks take the graphs and dashboards that have worked for them for years and say, hey, devs, here you go. And then be surprised or annoyed or dismissive when it fails. I think of this as the ones who are teaching have forgotten what it looks like to learn. And it's compounded by the fact that the vocabulary is often foreign and unhelpful. The first time I got yelled at by an ops person, I was releasing a new kind of product or chunk of our product. And a few weeks later, I had an ops person come by my desk and say, "Hey, Christine, our Cassandra throughput, our write throughput on our Cassandra cluster is through the roof. What did you do?" I went, "I don't know. I introduced the ability to send custom metadata to our analytics product, and users could query on it. I don't know how it ties to write throughput." Traditional monitoring tooling expects and uses almost an exclusively ops vocabulary: hosts, availability zones, CPU usage, memory utilization, disk space. They're not useless signals. They're just useless when it's a code change that caused the problem, and maybe a code change to be the solution, or a design change. I've listened to engineers who are new to a team describing watching the experienced operators on that team like they're like making leaps of intuition that are basically like magic. This sounds cool, but ultimately is awful for everyone. This glorifies maintaining that mystique. It tells developers you're only going to get good at production if you copy the way that experts, ops folks usually, do things. And it doesn't have to be that way. Understanding the infrastructure around your code, great. I probably should have understood how my code mapped to the right throughput. But it's not the only way to think about production anymore. It shouldn't be the only way, right? Imagine if that ops person or a tool had told me, "Hey, Christine, since you deployed your code, it caused latency to spike for this endpoint, for this type of user." Great, now I can take that, map it back to my code, map it back to my world, and use the skill set that I have to debug my code on my machine, or debug code that I understand. And this is a pet peeve of mine because I think developers are better suited for all of this anyway. Application logic goes wrong, at least in my world, more often than infrastructure. Instead of making ops folks decipher the code that changes multiple times a day, written by an enormous team of developers, enable the developers to get more comfortable in production. Because so many of the right instincts for catching problems in production are already in place. This is an example of a software development process. But if you look at it, it's already so full of this curiosity. Just look at the number of times a step involves the concept of testing, right? Of comparing the code that we think we wrote against how it actually behaves. We do this at each step along the way as the environment gets more and more complicated. Even this last step, which previously fell on the ops side of the deployment wall, it's a form of testing. Let me show you. Writing good pre-production tests is all about thinking through various scenarios, describing how the code should behave, and then investigating when it deviates from those expectations. The promise of test-driven development is that the more practice we get at this, the more we front-load it, the better our code gets, because we begin thinking ahead and explicitly examining our assumptions. Well, when folks look at graphs of how systems are behaving in production in aggregate, right, they're zooming out, they're doing the same thing. They're trying to figure out why the beautifully consistent behavior we expect on the bottom turns out to perform a little differently in real time. As we transfer what we do in our written tests to graphs describing what our code running in production, and we learn to work with those graphs and translate that back to our code, we will be the ones who are best positioned to handle it when expected behavior out there doesn't match the actual. Right. I have a necessary caveat here. There is a world where Some smart folks are trying to make development more like production. They're trying to make it easier to mirror production environments in development or production configuration, using containers to replicate more things on my laptop. It's not a bad thing, right? More complex development environments do allow us to simulate and think about more of the complexity in that safe environment. But at some point, the effectiveness of that approach breaks down. Some things only happen in production. And at some point, if you're at some point, midpoint along the way where you're trying to replicate the entire power grid or trying to copy the entire, Facebook scale production traffic into a dev or test environment, that just starts making less sense. And it's a lot less direct than just improving development awareness, developer awareness of what's happening in production. Okay, so what is the right way for developers to level up at production? I think there are two questions developers should always be thinking about production. One, is my code running in the first place? And two, is it behaving as expected? This first question is one that we find ways to ask naturally already all the time, right? When we're working with traditional monitoring tools and traditional dashboards, we used to ask questions like, hey, this user report that's complaining about weird behavior, when did it start happening? And then we would try to take that report timestamp and align it with some deploy timestamp on our graph and try to confirm that, oh, okay, well, they're hitting the old code, but the new code is deployed, and so it should be fine. A lot of guessing, a lot of using eyeballs to match things up. A friendlier way to do it is ensuring my tools use the nouns that are able to answer that question directly. Hey, graph, what build ID of code does this spike represent? Hey, chart, when did that last deploy happen? Hey, feature flag, were you on when a user hit this part? When this user's request hit your yes/no function? It's possible today to map that funny spike in a graph back to specific code and Git commits. Your tool just needs to support ingesting and querying high cardinality data like these. Easy. Because when you use multiple feature flags, you've got multiple ones live, you start to get this combinatorial explosion of all the possible paths your code is going down, independent of deploys. Makes it that much more complicated, and yet feature flags and progressive delivery are here to stay. So it's us and our tools that have to level up to support this new world of shipping software. The second question, is it doing what we expect? Just ties back to that testing behavior we already described. We developers all already do this. So how can we yank those tools that we use to observe production, traditional monitoring tools or modern observability tools, whatever you're using, to feel more like what we're used to using in development? Well, let's start by looking at those test cases we're writing. They probably talk about the logic of my application, not infrastructure. So this is where being able to capture nouns like user ID or functionality tiers like, are they a premium user? Are they a free user? Maybe your application does something different based on that. Time zone, API endpoint function name, all of these things allow a developer to pinpoint, is the code that I think is running? And is it doing what my brain thinks it should be doing? When we write pre-production tests, we know we're not going to be able to capture every single test case, but we still write representative ones. And so the paper trail that we leave in production for our future selves or fellow developers to use when comparing expected versus actuals has to be a paper trail that we devs understand firsthand. CraftConf has a delightfully international lineup of speakers and attendees. So many of us have felt firsthand how much language barriers can get in the way of understanding. To get developers feeling like we belong in production, the first thing to do, have to make sure production tools speak our language, not just that language of ops. And we should be taking advantage of the visualization and interaction patterns in production that look and feel familiar to developers. Tracing and distributed tracing is the most developer-friendly movement to happen to production in the last few decades. And it can make a scary production service kind of just look like another browser debug window. So let's take a look again at the software development process. Once this last step speaks our language, I can tie production back to that development world, and I can start to build these feedback loops. Instead of just, oh crap, I released something and something broke. Now I should write a test to reproduce it and go through this flow again. I can observe production to check assumptions during code reviews. I can use production data to make sure we're prioritizing the right things even earlier during the design phase itself. All sorts of exciting loops become possible and easy in a way that they never were before. This behavior isn't new. As an industry, we've been looking for ways to roll out some new code and check it in a new environment and minimize blast radius. Always. It's just easier than ever now. This story comes from my friends over at Carwow in London. Pedro and his team had a hypothesis for what was behind a poorly performing API endpoint. This heat map shows latency, and you can see the blue bar at the bottom is where most requests completed, usually pretty fast. But sometimes, under some conditions, performance would get really terrible. They had a hypothesis. They made a small change to test their fix in a small way, basically identifying a small slice of inputs that they thought triggered the bad behavior. And once they were able to use a tool to tease all that apart, to check, to slice this performance graph by types of inputs and part of the code, they were able to confirm that the change that they made resulted in improved performance. We're able to roll that fix out widely and drop the 99th percentile latency by 2 orders of magnitude. Again, responsible engineers look for feedback loops in their work already. Good tooling just shortens those feedback loops even more to make sure that engineering teams don't do wasted work. Because when you do this, that second question turns a little bit into something like this. Instead of is it behaving, it's will it behave, right? We can start to think ahead, check those assumptions, and move from being reactive to proactive. Because writing those tests relies on first defining those expectations. Well, we're better to set those expectations of what should be normal than by looking at production. What's normal performance these days? What are normal parameters? Are people actually using this thing that we thought no one would use? Another story, again, how bad is it really, right? Do I need to do this work? Are users actually being impacted? This story is from our friends at GeckoBoard, another UK-based company, who wanted to confirm that in this pair of heat maps, the latency spikes on the bottom are actually correlated with processes on the top, processes crashing and coming back online. They were able to check something before they wrote any code in order to prioritize what they were going to be spending their time on in the first place. Okay. So how do we break this big set of things down into a few steps that we can start to take today? Because one trap that I see people get stuck in is they go, okay, production, great. Let's get developers into production. Let's change everything at once. Let's introduce a giant initiative, make a big effort. It'll be big and splashy, and the way that we ship software will be revolutionized. It doesn't have to be like that. You don't go from 0 to 100% code coverage in a day. You don't go from no documentation to perfect documentation all at once. You're going to burn your team out. Everyone is going to get cranky, not want to do it anymore. Allow this change to be incremental and iterative. Find ways to get small wins to validate more effort. I always like to suggest that folks start to introduce observability or instrument their systems. Start with breadth. Start from the edge of your system, wherever, closest to your users. The closer to your users, the better. Identify the unit of work a user interaction triggers. For a standard web app, serving an HTTP request to your users is there's that edge, and the HTTP request is our unit of work, right? And it enters your system through that HTTP handler. So great. We'll capture breadth by capturing some instrumentation in the handler, maybe middleware, right? That's that first place to hook into your code. The goal here is for it to be lightweight to capture, lightweight to think about, maybe generic, but broad. So you can get a big picture of what your system is doing, what your software is doing, and a little bit of, again, what normal is. Then go deep. Find a single code path or part of your system or feature that is painful. This might be because it is a complex sort of legacy part of your system that no one has touched in a long time. And you want to make sure it's stable. Maybe it's the payment path in your system. This can't go down. This can't have problems. We need to make sure it is fast and reliable. Great, start there. But the point here is to basically do the opposite of what we did with breadth. To think deeply, to go deep, to capture as much detail as we can so that we can get a little bit more information to address that pain, to prevent that pain, to show the value of if we instrument, we can see into production, this is what we can do. Instrument from where you can control. So again, let's use a standard web app as an example. By instrumenting our application, place where I, as a dev, am the most comfortable, we can capture what arguments were sent to it on any given HTTP request. We can capture some metadata in the app about how the app was running, and we know what was returned. What about this database, this black box that the app depends on? What's happening in there? Well, I don't know. And even though most databases we use these days are open source, I'm certainly not going to fork MySQL just so I can shove instrumentation inside of it so I can see what's happening in production. But I do know what MySQL queries my app is sending to it, from where in the code, on behalf of which user. And I know how long it took to respond, whether it was successful, and if I'm lucky, extra metadata like how many rows were scanned. By capturing all of this around the database, all of this from where I can control, I can still start to reason about how inputs impact the outputs of my black box and how the inputs to my application impact all of that. The last, capture what matters to you. Now, you here might be the individual developer. You here might mean your team or your business. Only you can decide what matters when you need to debug something in production. Maybe you, the individual, need to be able to figure out whether a request hit your experimental code. Maybe you've got something behind a feature flag that no one should ever hit. Maybe you want to be able to quickly identify calls across service boundaries. Is your code waiting for a call to another team's service to complete, and that's where it's timing out? Are all failing requests talking to one specific database cluster maintained by a team based in New Zealand? Or, you're an airline site and leadership has decided that it's especially important that frequent flyers never see errors or slowness. Okay, well, let's make sure we capture those business level identifiers so we can show the business leaders This is how engineering is servicing the business. Because where that metadata comes from, whether the metadata is about your infrastructure, your specific deploy, your business, or single execution of your code, that context is key for debugging, for isolating unexpected behavior in your business logic, or deciding whether you really need to wake up a teammate to help deal with something that maybe you can't quite figure out in production. Now, we've talked about some technical pieces here and some human pieces here, and I like to try to separate them out before you all go off on your days. On the technical side, we've talked about distributed tracing as visualization, as a type of tool, something that looks familiar to developers. We talked about support for high cardinality data. We've talked about capturing a baseline of instrumentation and then customizing it, making it your own. On the human side, right, we iterate to improve. We break something down into small bite-sized chunks so that people, your developers, are willing to and excited to incorporate instrumentation and observability into their workflows. Right? With testing, again, we know that the easier we make it to write a test and to run a test, the more likely developers will write tests in their pull requests. Great. Think of instrumentation like that as well. It's exploration and curious piece. The thing that I love identifying about technical parts of getting comfortable in production and human parts, they're not just two halves of a whole. Adopting one amplifies the other, right? Adding high cardinality data makes it easier and more exciting for developers to be curious about production. Because you can say, oh, okay, what did happen after I deployed that? What does happen for these users? Why are there these outliers? What's going on there? Because it's not scary anymore, because they're the words that we understand. And embedding, we talked about embedding these practices into your existing processes. In a code review, in a pull request, can there be a section about how will you know whether this code works in production? The same way you have maybe a section about which tests, what is your testing plan for this thing that you're pushing through? These two sides amplify each other, so don't pick things from one column without thinking about items on the other. The tech involved in getting our code into production has moved forward a whole lot in the last decade or two, right? We developers don't need a whole crew to ship our code anymore. The space between development and production has shrunk. And in many cases, it's magically hooked up to my natural workflow through something as lightweight as a Git commit. So we developers had better be ready to adapt, or we will risk being left behind. Because the future of development and developer careers is in production. At the end of the day, the racetrack shuts down. You've got to get back on a highway to get home anyway. Prod is unavoidable. It's a whole lot more fun anyway. Just make sure to do the responsible thing and make sure you can see where you're going through observability. I think we have time for questions. If anyone wants to get a hold of me later, you can always find me on Twitter. My DMs are open. Thank you.
Thank you so much, Christine. Awesome topic. Really, DevOps is core part of all the way from software, from zero to the end, from building it to production. And I just feel like it's always secondary. It's always secondary when you build the software. You just want to focus on code, and you want not to think about DevOps. Honestly, I am a developer, and I'm not really good at DevOps and the definition. I try to hide from it. But the truth is, we should get closer to this. And so in our experience in the company where I work at, I also feel like we are just afraid to use new tools, and we always stick to the old way, stick to console logs. What do you recommend to those who might feel that they are stuck? What should we do when we feel like, and how can we measure when we are being stuck and when we need to use some new tool, refresh our tool set?
I think they're always going to, the what you're familiar with is always going to feel safer and more comfortable. But that's where I think that, that go deep, that pain piece I mentioned comes into play, right? There are probably some parts of your system that are really annoying to dig into with console logs or whatever your existing tool set is. And so, if you are the one on your team playing around with something new, don't scare off the rest of the team by saying, we're all going to switch over to this new thing. Say, hey, I'm trying out this new thing. This thing is painful over here. I'm going to introduce, I've added some instrumentation around tracing here. Look how much easier it is. But making it not feel like a big, scary jump, right? Not making it feel like a leap across a chasm, but instead one step. Hey, look how much better that is.
Right.
Hey, let's look for more opportunities to add instrumentation. Let's look for more opportunities to use this new tool, and slowly kind of build up that comfort level and confidence and competence.
Let's teach each other use these tools. And just us in the company, I was thinking while we were talking about, because DevOps is all about, as I said, from zero to the end. It has continuous integration, testing, log management, error, all this. And in the company, we use a bunch of tools. Even for logging, we use 3 different tools. For error checking, 3 different tools. For deployment, 3. Do you like this? What's your opinion on this? Do you think this is unavoidable? And maybe you can tap into Honeycomb, because I feel like Honeycomb is trying to formulate everything into one place. Do you think this is possible? This is the future. What's your take on this?
I'm going to go on a little bit of a rant here. I'll try to keep it short. So when you look at the types of tools that we have, right? And I'll just pick on logging tools and monitoring tools, because those are the 2 big buckets. For so long, we all just assumed, oh, this is normal. You have one thing to look at, graphs, and then you have one thing to dig into logs. But if we look behind us, the reasons we have those 2 types of tools is that when we first started writing code to execute on a machine that wasn't ours, we had grep and we had counters. And that was all the hardware could support. And so people were like, okay, well, I'll use grep for these things and counters for these things. And then as time went on, grep became distributed grep, became, hosted, self-hosted something, UI around a distributed grep became these logging sesses. That is how we ended up with these 2 buckets of types of tools. Is that how it always should be? Is that the right thing? No, it's just inertia, because we've looked for local maxima on how grep and counters can evolve. Honeycomb's whole mindset is, hey, look, we are not architected in 1990. We are architected in 2016. We have SSDs, we have serverless, we have column stores, we have approximation algorithms. We have the ability to reimagine what does it look like if, instead of taking reality and slicing it in a bunch of different ways to shove into these data stores that we're used to, what if we found a way of representing a thing that happened, HTTP request your services handling, batch job, something, representing it in a flexible way, and then post-processing it to spit out whatever visualization or aggregate that you want, right? What is a metric if not logs that have been processed? What is a trace if not logs that are grouped together? It's all connected. Yeah, and the idea that they should be different tools is it's leftover. And I think we're moving away from it.
So you are challenging this, and I kind of feel you, because each tool has just a little more that it says, but I wish it was one together. And I think Honeycomb, does Honeycomb try to fix this and actually tries to be, because I can mention, names like Sentry and etc. These are all your competitors. Are you really trying to be the one that tries to encompass all these things into one place?
I think we can be. I think there's going to be, there are some of those tools focus more on workflow than exploring data, right? If you think about Sentry, the thing I love about Sentry is how you are working in a team, you can mark something as resolved, and there's that feeling of I'm going through and handling my exceptions. And you've got this list of things for me to deal with. that is separate from help me understand what my software is doing, right? My whole thesis is software is getting more complicated. Not everything is an exception anymore that we need to pay attention to. What about the things that happen before exceptions? What about some things that are just a little bit weird that would serve us to understand so we don't make things more weird? I think, we developers like to build tools. Right. And so we always think we can do something a little bit better. And so there's a lot of options out there. But for anyone listening, I think the key is what past is that tool grounded in, and what future are they trying to build towards? Is it just another local maxima?
Look, I tend to agree with you, and I do suggest everyone check out honeycomb.io. And I've got one more question, but there are two questions in the thread. Diego is asking, how do you, or maybe this is for the previous, this is already answered, sorry. Then one question from Anonymous, how does the same look like from an ops person's point of view? I'm not sure, do you understand the question? Because I don't. But how does
I think the question is, well, do we need ops people anymore?
Okay.
Like what does that mean? And the answer is absolutely. Right. I think SRE is moving, SRE is the new ops, but that's the silly way of saying it. But I think that there is a lot of still, skill and opportunities still for blending. What does it mean for the code that developers writing to be running in certain infrastructure? What things should developers be thinking about in production? What do they need to know? What don't they need to know? I think that there's, looking at how the different types of instance types talk to serverless functions, and what, there are more components that are not code that we are still playing with. And just like developer careers, ops careers are changing. It's just a different set of nouns. And I think increased focus on the human factors, increased focus on what practices are important, what are where do we need safeguards versus where should we be removing safeguards? My co-founder is more of an ops person, and she talks about this much more eloquently, but I think there's a shift overall, because we are all having to re-examine what we are going to do in this more complex world we keep building for ourselves.
Yes, we need to speed up, that's for sure. And we need DevOps tools for sure. One more question I've got is, what do you think, because say I start building an app tomorrow, and just a startup, something for myself, side project. When do you recommend the developer to start focusing on DevOps? Is it right in the beginning, or deal with it later? Like, hooking in tools like this, like for example, Honeycomb.
One of my friends will say, she's got a great blog post about how this is one of the first couple things that they do in production. One of the first couple things that they do when starting an app. Think about Rails, right? It is something that we think that we're familiar with, but there's so much complexity under the hood. What is it really doing? When you write, when you do a model.find, how many SQL queries is it actually kicking off? I think that there's value in understanding it, even when you're the only person using it. Sometimes I get a little more lazy, and I think my bar is, before someone else starts to use it, it's not just on my machine, that is the absolute bar.
I see.
There should be some way of seeing, what did they hit? What behavior are they seeing? And is it what I expect?
Right. I agree with you completely. Christine, thank you so much. For more questions,